Oh, well, fancy meeting you here at the Daily Space Weather Show. Just looking at some 24-hour videos here of the closest star. And we've got a new most active sunspot. We'll cover it and plenty more today. Here at the Smash News Network, least busted name in news, we've got a bunch of setting groups there. 3 major setting sunspot groups in the western limb. Their likelihood of producing a large flare remains in effect. That doesn't expire for another 36 hours plus. However, the most important is this new sunspot rising in the southeast. So it has produced an M7.6 class solar flare, I believe it is. We'll cover it here in a few minutes. So that is our new TMAS, the most active sunspot. It doesn't even have a name yet. And there is an extreme close-up of its past 24 hours of activity. That's 30 frames per second, SDO 171 angstroms, 24-hour video. Now, yesterday we said there's a 100% chance of coronal mass ejections, and indeed, there have been 2 noteworthy ones since yesterday. And we'll cover that here. And by the way, thanks for tuning into the Smash News Network, least busted name in news. If you enjoy the content, make sure you press the like button, press comment, share, etc. Press the things. Visit the links below the video. Perhaps pick up some Smash-O merch. Thanks to everybody who has. And I think we're going to stick with including a quote on the daily space weather content. It's better to fail in originality than to succeed in imitation. That is, don't follow fads, set trends instead. That quote from Herman Melville. And let's get into some space weather stats here. The radio flux now at 196 solar flux units. 196 is the radio flux. There's the past year. You can see higher highs and higher lows being depicted there over the past month or so, and that's no surprise, as we're still a few months out from solar maximum, expecting that to arrive sometime around October of this year, 2024. Space Weather Enthusiast dashboard here, NOAA's forecast, not including any space weather events. It's pretty dreary. Well, if you consider space weather events to be, I guess it's clear sailing out there, right? It's not space weather stormy. And yeah, it looks like ESA agrees. So everybody in agreement here. No new space weather on the way is likely. So here are the past 4 hours of what Earth's magnetic moment from space may look like. That depicts magnetohydrodynamic pressure out to about 12 Earth diameters. So you can basically see the location where the inner Van Allen belts are, and where the outer Van Allen belts will be located there. Here's our ground magnetic perturbations map. We did get up to a KP3, but things are geomagnetically calm. So don't expect to see any aurora at mid-latitudes or something like that. Normal aurora at normal Arctic locations probably will be visible tonight, but no major space weather events. KP 2.33 is the current state of average earthly global geomagnetism. 2.33 is the KP index. Solar wind is slow and diffuse, so a little faster than yesterday, but quite diffuse. That's the measurements from ACE. A little over 4 protons per cubic centimeter for the density. Velocity here, 343 kilometers a second. Discover showing even more diffuse and a similar velocity. Velocity at Discover, 362. Density only 2 protons per cubic centimeter. There are our GOES magnetometers, and they're located in the outer portion of the outer Van Allen belts. They orbit at about 23,500 miles of altitude. They have a geosynchronous near equatorial orbit, the GOES 16 and GOES 18. Next, magnetism in the heliosphere. Earth is in a North Pole-oriented magnetic sector. expect that to continue for a couple of days, although we do see some magnetic turbulence over there in the east. So there could be some shifting around of coronal holes going on. That is what you call a forecast based on the magnetic data. Turbulence in the east. Here's our line of sight field plot. And some of this information, you're only going to be able to understand it if you immerse yourself in the data and you know what to look for and how all the variables relate to each other and so on. This is depicting the solar B field in blue, polar fields in red and green for south and north respectively, and grayscale for the photosphere. The layer of the sun under the corona, under the chromosphere, where sunspots occur. The photosphere. Next, coronal holes, and you can expect to see North Pole-oriented coronal holes mainly on the Earth side of the disk, which is what you see. That is what you'd expect to see when you're in a North Pole-oriented magnetic sector. And no, coronal holes are not correlated with earthquakes. Here they are from SDO 211 angstroms, and that's another 24-hour video, 30 FPS. It's also good at showing filaments. You can see some massive filaments there just moving to the western quadrant of the Earth-facing solar disk. One of the largest filaments we've seen in over 6 years. Moving to sunspots next. Sunspots. They're at 160. 160 is a sunspot number right now. And hey, look. Higher lows depicted in the past 2 weeks. Not really a surprise, again, because we're still a few months out from solar maximum. So we'll have, let's see, I believe there should be 2 new named sunspot groups, but sunspot number will drop tomorrow because of so many active regions setting there in the west. So I don't think enough sunspots have risen to replace all of those. So it's going to be a downtick in sunspot number going into tomorrow. But we're not entirely sure what may be behind that eastern limb. So there could be some activity that we're not seeing evidence of yet. But it looks pretty calm there. So yeah, we'll have sunspot 3723 and sunspot 3724. I think we'll get names by tomorrow. And 3724 is the T-mass. So that would be the farthest southeast. And it has produced a significant M-class event. So let's, there we go, cut into the ever-popular SDO. Ah, yes, the Solar Dynamics Observatory. Good times, good times. And we do have some umbral consolidation happening there in the southeast. But besides that, not a whole lot of changes going on. Things are looking fairly stable. So we still do have a large solar flare possibility, a solar flare watch there on that western limb right up there. That's not gonna expire for over 36 hours from now, but I would have to say the most likely place for a large solar flare would be the most recent large solar flare producer, Sunspot 3724, not named yet, all the way down there in the southeastern limb, your screen lower left. Here are magnetic fields, also from the SDO HMI instrument. And yeah, so major flare watch continues in the southeast as well as the entire western limb. Moving on to solar energetic particles and flares. So, ghost proton flux here is flatlined, but if we do see a large flare, that'll greatly increase the probability of seeing a spike in the proton flux. Right now, no such spikes. As far as the X-ray flux, there is our largest flare of the past 24. It was an M7.1. M7.1 class flare. Not too bad. It was in the southeastern limb. There was also an M-class flare in the northwest, and we'll show those on different viewing platforms. And by the way, just a little side note. Wait a minute. Wait a minute then. Right. So, yeah, there's the largest flare, but let's cut to this for a minute. So there's 94 angstroms, the full disk view. You'll see that larger M flare in the southeast. That's more recent. And the smaller one in the northwest. That was earlier this morning. And just a little side note about 94 angstroms. You know, it's part of the extreme ultraviolet light spectrum, so not only is that not visible to the naked eye, but it's not visible from the ground level, as the ionosphere absorbs extreme ultraviolet radiation. 94 angstroms is a temperature of about 6 million Kelvin. It represents iron that's lost 17 electrons, so it's extremely hot iron gas, a very tight portion of the electromagnetic spectrum. 94 angstroms, or you could say 9.4 nanometers. So that's what the 94 angstroms wavelength is. And here's an extreme close-up of Sunspot 37. I can't remember the name, but 37 something, 3712 is it? So earlier in the day, right in there, there's the M-class event from that active region. And we'll cut back to the SDO browse data feature. So around 1300 Universal Time today, we had that larger solar flare. And again, like I said, going forward, that will be the T-mass, the most active sunspot of the past 24 hours. Here's the full disk view in 131 angstroms, a full 24-hour video at 30 FPS. So very high likelihood of major flares, something that we like to see because space weather is cool. It's cool. And another side note, 131 angstroms is also ionized iron. It is two different species. That is iron 20 and iron 23. So, yeah. And that's the hottest temperature covered by the SDO. That's 10 million Kelvin. Some pretty hot gas. Extreme ultraviolet light is the wavelength. So here we just brought up the electromagnetic spectrum here just to sort of show you that, to show you the difference between radio waves all the way up through visible light through to gamma waves. They should really call it gamma rays, not gamma waves. But hey, it's from NASA, so it's like whatever, it's fine. And just a quick reminder, the human eye is only able to see that tiny portion of the spectrum there, of the visible light spectrum. And electromagnetic radiation, kind of important to understand when it comes to talking about things like space weather. So anyway, here's our solar system forecast before we get to coronal mass ejections. Solar system forecast. Things today are here. Things in 1 week will be a crescent waning moon on the 30th of June, and things will be there instead of here. Next, a quick look at a star chart. That's what's going on over my head. Mars just setting there over the western horizon when we record this video. It was recorded at 3:53 p.m. Eastern Daylight Time. Today's astronomy photo of the day is Saturn. It's not known why the cloud tops are blue in the northern hemisphere of Saturn, but not in the southern hemisphere. So that's one of the mysterious things. Also, look at how weird Saturn's rings look when they're viewed mostly edge-on. So that's pretty interesting. They do cast some interesting shadows on the planet. apod.nasa.gov if you want to check it out for yourself. From Cassini. That was from 2005, from the Cassini Saturn orbiting mission. Moving on to CMEs, and we ain't got none from George Mason University. Here are today's events. There were two. There's a more recent one, and going back, there is the less recent one. It was around 8 o'clock this morning. Actually, that's a long outflow there. Sort of like multiple CME events, not earthly directed, and that other one also not earthly directed. So no new space weather incoming. We'll also show stereo A. Well, it's actually lacking some data. It'll show that Western CME, but not the other one. It's also showing, that's Mercury up there, I think it is. No, that's Venus, I think. That bright body there, that is Venus. And moving on to our custom coronagraphs, which are totally freaking sweet. Synchronizing the SDO and the coronagraphs together, that's always nice. Great light show for you there. And here we've added the 193 60-minute running difference imagery to the SDO to give you a little bit more contrast on filament motions. So yeah, not earthly directed CMEs. And let's move on to filaments, because filaments are pretty sweet right now. Check out the MJ filament. That's the one sort of closest to me here. The Michael Jordan filament. It's massive, and we've certainly got 1, 2, 3 more that could use names. The one in the northern hemisphere, and then 2 more in the southern. And if you want to name filaments, go follow us over on X, aka Twitter. I try not to say X because, you know, a letter isn't a brand, and it can't be a brand because it's a letter. You can't try to, like, copyright or trademark a letter. That's why we don't use it for branding. It's some basic stuff here that kids in junior high would be able to comprehend. Anyway, there's the grayscale imagery. Let's cut to our filamentary views. Actually, let's show the GOES 16 SUVI. They're the past like 2.5 hours. And we still do have lots of plasma instability down there in that southwestern limb. So southwestern limb is certainly another area where we can really expect to see a CME. That is some very unstable looking plasma. And there are some quite volatile looking sunspots just to its north. So there's that. Also that southeastern limb. And of course, we've had some M-class flaring from the northwestern limb, so lots of places where we could see large flares moving forward. So here are filaments from SDO. We've put together just the 193 angstrom 60-minute running difference along with the 304 angstroms ionized helium wavelength. And yeah, the Earth, well, I'll say the sun is currently loaded for bear. There are lots of very, very massive filaments kind of pointed at the Earth. So you can see some of them in the northern hemisphere there. There's the equatorial view. And of course, in the southern hemisphere, no less than 3 really massive filaments down there. So again, the sun is currently loaded for bear, and Earth has a lot of plasma kind of pointing at it. Pointing at it. It might not be obvious from that imagery, but those things are hundreds of thousands of kilometers in height. The sun's atmosphere, known as the corona, is very bumpy. Very bumpy. So there's the full disk view. And let's get the bonus features. Bonus features. So first is the GOES 16 SUVI charging hazards. There we go. We have some minor surface charging happening there over Southeast Asia. Southeast Asia, some minor charging hazards there, unlikely to cause major communications failures. We do see a plunging of the electron flux. So the electron flux here rapidly dipping throughout the day today. Here's the forecast model. It looks like NOAA kind of called it. So there you go. NOAA called it that time. Next, the ionosphere, and we're going to be showing the F-flare. Feel free to pause the video on this frame if you're not familiar with the temperatures and altitudes of atmospheric layers, the penetration of electromagnetic radiation, and the chemical concentrations of the atmosphere. There you go. There's the F-flare. And I gotta say, it's looking really, really, really average. not anomalous except for, well, you could maybe say the South Atlantic anomaly having moved is a little anomalous, but besides that, it's looking really average. Here you'll see quite a bit of high and low frequency anomaly shown in blue and red respectively. That's anomaly in megahertz from a 30-day median, and that's really nominal, not anomalous. So we apologize if we were unable to say something spooky about the ionosphere, but not spooky in any way. Looks really normal. Here's our global ionosphere nowcast. It'll help to show where the most likely places on planet Earth are for things like GPS errors. And of course, the use of different radio frequencies. It's the Global Ionosphere Nowcast, or WHAM, the whole atmosphere model. Last but not least, the latest high-res images of the closest star. So we'll take a look at these while they're still visible. Certainly beta gamma class. Not sure if it's delta, as the view is getting pretty bad. Let's bring that back. We'll take a look at this one as well. Again, a pretty bad view there. And most importantly, this sunspot group down here. So that is our TMAS, or most active sunspot. And it looks like there are more umbrae to rise there, so that's always good news if you want to see higher sunspot numbers. Oh, and by the way, just a quick meteorological note. If you're noticing a lot of forecasts have been failing, look at all the Saharan dust that's making its way across the Atlantic. That is going to be catastrophic for the current hurricane development. So for all the fearmongers out there who want to see hurricanes, major hurricanes, make landfall on North America and things like that, the Atlantic hurricane season has had the kibosh placed on it by that Saharan dust. So just so you know, that's nullschool.net. That is the current state of dust, and it's really dusty down there in the tropical Atlantic. So anyway, I just figured I'd share that, since there are plenty of fearmongers who do space weather. And by do, I mean flap their lips and babble utter nonsense about space weather. Anyway, it's time to close this thing out. So ta-ta, ciao, cheerio, auf Wiedersehen, and so on. I've been your host, Dan, a.k.a. Smash-O-Mash, and until tomorrow, may that solar wind be at your back.